Welcome to Syntax. Today, we have a really good one for you. We have Dimitri Mitropoulos here. He is the mastermind behind Doom in TypeScript, along with Typeslayer and a bunch of other just wizardry, just straight up wizardry. So we're going to be getting into all kinds of TypeScript topics, but even getting into local meetups and just a lot of cool stuff. Dimitri is incredible. So Dimitri, do you want to give us a little rundown of who you are and what you do?
Yeah, I'm a TypeScript developer, whether I like to be or not. I've tried so many times over the years to, go in other directions, but it's so near and dear to my heart. I've been doing this since like the Angular 1.0 days. I used to be diehard on that. Multidisciplinary is the thing that I like to do. So I like trying new things that I've never experienced before. We'll get into it, but the Doom and TypeScript Types project came out of that. Like so many of the things that were necessary for that, I had no idea about before I started. And I live in Michigan. Yeah, love the cold weather.
Hell yeah. Yeah. You from Michigan originally?
I sure am, yeah. I went to Massachusetts for grad school, undergrad as well. I have 4 degrees in things that are not computer science.
Crazy, yeah.
So definitely like to learn, but, Then I came back.
I'm from Brighton, Michigan originally, so grew up in that area. My wife's from Canton, so we,
awesome.
Very Michigan people. My parents are still over there. Love to get to Ann Arbor anytime we can. So, Doom in TypeScript. For people who may have not seen this, can you explain what the hell that means?
This is literally, to preface this is absolutely nuts that you did this, and anyone listening should buckle up. So go ahead.
I wake up sometimes in the morning and I think to myself, it's been a year since that was complete, more. And I sometimes wake up and I think, I wonder if it's possible. And that's probably the best way to explain it. It's a thing that you would think something like that about. You just I had this nagging thought, I wonder if it's possible. And actually, basically the entire time I thought it wasn't possible. So what's the what? The what is, Doom is a game. It shows pixels on your screen. You push keys on your keyboard and things happen inside the game engine, okay? Abstractly, that's what it is. And TypeScript is, people have to separate the type system and the runtime language we call JavaScript. So when I say TypeScript, I'm talking about the thing that's running on top of JavaScript, the types. So the question is, can Doom, the game, run in TypeScript types? Just the type system. No, absolutely no JavaScript whatsoever. Not a single line. The DTS file is 0 bytes. Yeah, no JavaScript. All TypeScript.
So to be clear, this is not you writing a canvas and running Doom in the browser with JavaScript.
No.
TypeScript, I don't think a lot of people understand this. TypeScript is a language, right? It's not, obviously it's something that converts to JavaScript, but TypeScript itself, the types, that's its own programming language, right?
Yes. So the type system has been known to be mathematically Turing complete for many years. And this is something I have a big issue with, actually. So people talk about this concept of mathematical Turing completeness. And I think it's baloney. I think, imagine I told you I have this thing and it's Turing complete, except it takes longer than the heat death of the universe to calculate 1 + 1. Is that interesting? I guess to mathematicians somewhere out there, it's interesting, but to me, it's not interesting.
Yeah.
And I've come to realize, actually skipping ahead to the end, I've come to realize after I released it, some people educated me a little bit. Doom itself, the game, is Turing complete. There's a way you can set up a level with different doors and gates and things that you can make a Turing machine. And so actually Doom complete is the better metric, because if it's Doom complete, it's also Turing complete. But we're getting in the weeds. The big picture is, how do you even show, TypeScripts are just strings and text. How do you even show it? And so these are the questions that I had in the beginning that I'm oh, okay. People say that, it's Turing complete, so it should be, it can run anything. And I just think that's wrong. I think it's it can't run Doom. And I thought, all right, I'll find a way to show why TypeScript types cannot run Doom, and that's going to be the project. So I thought it'd be a 2-week project. I didn't think it would be this long, year-long section of my life. But I thought I would quickly arrive at the immovable object, the unstoppable force that we would hit to show why it's not possible. And that was the mindset that I started off into this project with, including how to even show it on the screen. That was one of the first things I had to figure out.
Man, so what does that even look like for in TypeScript where you
Yeah.
want to show a pixel on the screen and you want to write a function.
Yeah. Well, so taking the first one, we've all seen like pixel art that's turned into text. Like people call it ASCII art.
Yeah.
I've also learned it's not technically ASCII art because you use characters outside of the ASCII 128 whatever. I call it ASCII art. Yeah. UTF art isn't as cool. So people draw pictures with monospace characters, and if you think about it, a monospace character is the aspect ratio of that rectangle is roughly like 2 blocks high and 1 block wide. And so if you take 2 of those, then you have like a square. Okay. Now think again. Okay. Well, like different things I could put in those 2 boxes constitute like an average number, like an average color. Like if you have white text on a black background, there's like an average color. And so like from there, you can kind of calculate like, okay, I'm going to create like shades. I'm going to create pixels of, going from totally black, which is just spaces, and totally white, which like there's a character that's like a square. You can just put them next to each other. And then I'm just going to create like a gradient in between there. And now I have like, 256 colors, like a grayscale picture that I can start to draw. If you kind of like zoom out far enough, you can see an image. And that's the basic, getting TypeScript to show that is a whole other thing. But yeah, that's the basic idea. And in fact, the first week that I started on the project, like the first thing I did that I thought, oh, this is not going to work, was to try to draw a little ASCII art picture. I drew a little heart actually, just to see like, can I control this with types alone? And yeah, the answer was yes.
Oh man. And I watched it, and that was probably what, like 8 months ago or something like that.
Yeah, that's what I got.
Like how long did it actually take to like compile it, or like what does that actually look like?
Yeah. The final run happened in 11 and a half days. It was actually the night of Halloween. My kids were like, come on, Dad, we gotta like, let's go. And I'm like, okay, just one more. I just want to like start one, because by that point I had run it. I have all the stats. And so I have to say as a preface to this, I've been working on it forever, but I've been very busy with other things. But I'll be putting out a video explaining the whole story. It's going to be like a very long video, but I had been running it and failing constantly failing. So like there were multiple runs that lasted many days before the final one. And I was able to figure out roughly how long it would take. And my cutoff was a month. I was like, as long as it takes less than a month. I had a computer in my basement, and it's like constantly doing like running TSC in a loop, doing the type checking. Like as long as it takes less than a month, I think it's cool. So that was the final run. Took a year and a half leading up to that point, though.
Oh, that's hilarious. And with the TypeScript Go, this was before the TypeScript Go stuff, probably by a couple of weeks. But did that speed it up? Have you been able to get it run in the TypeScript Go stuff?
So I'm sure it would run because it doesn't use it. Actually, the funny thing is people look at it and think like, oh, they must be doing lots of tricks. And there are a couple tricks, but like not more than 5 or 10. It's actually like very simple things built up in like Lego blocks. For TypeScript Go, it would work. I have made a promise to myself I will never touch that project again.
It's a closed door. Yeah,
it's a closed door. Yeah, no, like if somebody else wants to do more than Doom, like that's fine. And some people, one of the top questions on the video when I announced it was like, well, how come you didn't show gameplay? And it's like, well, I don't really find that very interesting. Like the whole point of the project was to really boot the game, because you got to think there's like a physics engine, there's like a map drawing system, there's like a sprite system, there's a character, there's texture mapping, there's like item inventory management, there's panels on the screen, there's like all this stuff had to be encodable, sound engine, all had to be encodable in TypeScript types, and I did that. Like one frame of the screen is like completely rendered is enough to prove that you did that. And all that it would take to do more is just like letting it continue run. But I'm not, if you do 100 frames, someone might say, why didn't you do 101? So it's like 1 is perfect enough for me. Yeah.
And if you want to see all of the errors in your application, you'll want to check out Sentry at sentry.io/syntax. You don't want a production application out there that, well, you have no visibility into in case something is blowing up and you might not even know it. So head on over to sentry.io/syntax. Again, we've been using this tool for a long time and it totally rules. All right. Your latest project that just dropped, and the YouTube video, we should say, is woefully underviewed right now. It is Typeslayer. It was a really cool, you said it's a Tauri app that you put together for all kinds of TypeScript performance diagnostics. And this thing is another incredible deep well of just magic. So can you talk a little bit about what Typeslayer is first and foremost, and then I want to get into like, why does TypeScript performance even matter? Like, why is it something users should care about?
Totally. Typeslayer is a tool, like you said, for diagnosing TypeScript performance problems. And again, when I say TypeScript, I don't mean like JavaScript. I mean the type system. And it was born directly out of the Doom project. So in order to do that, make that Doom project happen, the hardest part was performance. The hardest part is like, how do you even... It's like a lot of data. It's, like, I think it was like 177 terabytes of TypeScript types in the end. So like, and not all of that was ever stored at one point. It's in memory on my computer, and like I have to clear it, and there's like things I had to do. But when I started looking more about how you even go about diagnosing what TypeScript is doing under the hood, it's really hard. I mean, it's prohibitively hard for almost everybody. Like, I mean, there's a process where you can generate these JSON files, and they're like, could be hundreds of I was saying hundreds of megabytes until recently, but now I released Typeslayer and people are sending me their 5 gigabyte JSON files, where they have monorepos with 3,000 packages, and they need 80, one person, not 80, it was, they said they need 60 gigs of memory to type check their project. Okay. So that's like not normal, let's say.
How big are these projects? Because like we had the TypeScript folks on, and they told us like they're allowed to talk about some of the projects, and then off camera they tell us about some of the other big projects. But there are like many millions of lines of code that takes 60 gigs of RAM to just type check it.
Yeah.
Hokey.
Yeah. So the thing is that's interesting, and so I've been in the position since I did Doom, like I have to stress to people listening, it's all fun and games with the Doom project, but what I really hope that people take away from like these projects, Typeslayer is one of them, personal projects are so overpowered for creating knowledge that you can apply in a very expert way at work. Like
totally.
You can definitionally cannot get the experience that would really push you and propel you forward at work, because at work, your job is to take things off the shelf. I mean, you should not be reinventing the wheel. But in order to really understand the wheel, sometimes you do need to go into the wood shop and make a wheel. And even if it's just a toy, like you're going to come out of that with knowledge. So I came out of the Doom project with a lot of knowledge, and I applied it at my company. And it was interesting, like I found problems that solved would take, like one of them I took 100 seconds off the CI by basically a 5-line fix.
Wow.
And how does that happen? And the reason it happens usually, I think one of the big reasons is like you do something accidentally. You use some Typefest utility or some, I'm not trying to pick on Typefest, but like you use some abstract TypeScript type level modifier, and you don't really realize what it's doing. Or maybe it's just not good under the hood. Mm-hmm. And it creates this explosion of types. You have usually there's like a matrix multiplication of two types that creates this like runaway train. And, TypeScript has to go do all that work to kind of like figure all those combinations out. And it doesn't show you that though. It's all under the hood. So like the thesis with Typeslayer is let's expose the guts. Let's show people what's under the hood. Let's show people what, you want to see the biggest union in your project? Like it tells you. You want to see the type that's most frequently the part of the most number of unions? It'll tell you. You want to see like whatever it is, you want to see, and a key thing it also does, the last feature that I'll highlight, we've all seen this problem where you have errors in your code base and it's like, TypeScript has reached an infinite this or that, excessive depth recursion, something, and you're like not sure what to do about it. And you may have at times done a little TS expect error or TS ignore on top of that. But
some
if
of
you work
us,
some of us. I certainly have. So if you work at a large enough company, like a company like Century, actually, I mean, Century has a nice, large open source code base. Like if you're in charge of trying to make sure that code base is healthy, how would you know? If somebody went in somewhere, they got that error, the complexity limit error, that means TypeScript is working really hard on something, so hard, in fact, that it gave up, and they ignore it, how would you find it? You can't. There's no way right now.
Yeah,
there's no way to find
yes.
it. Yeah, right. But Typeslayer shows you immediately. Like if there's a screen, you just pop in there, and it shows you all of the errors of that sort that were hit in your project, and then you can just go to those files and just see what was happening and maybe address them. Because what people don't necessarily know, and that I really want people to understand, is when you TS expect error a diagnostic, all you're doing is hiding the diagnostic. You're hiding the red squiggly in your editor. You're preventing it from stopping on the CI, right? But you're not.
Isn't that what we're all after? We're just after removing the red squiggly.
But if it adds 100 seconds, would you change your mind?
Or you need a supercomputer to type check your code base.
I'll just get a Mac Studio. doesn't matter. Yeah.
Mac Studio.
Yeah.
So yeah, that's so there's more to it, but that's the basis of like what Typeslayer is. It was actually the name was given to me by someone who commented in the TypeScript Doom YouTube video. They said like, and they call him Typeslayer because in Doom, I think his name is Doomslayer is the character's name, right?
Yeah.
And I just for a long time had it in my mind. We're like, oh man, that's such a good name, but I'm not the type to have a moniker. What should I do with that name? And then I came about this. And I was like, oh man.
Yeah, that's the video is a great watch, and I was really just kind of jaw agape the whole time, and especially because we deal in such smaller type systems many times here, just that like the types of issues and problems that people are facing. So you built this thing in Tauri, which we've talked about on the show before. Tauri is a toolkit for building desktop apps using the native browser that comes like the web in for Mac WebKit. How did you find working in Tauri? Because I've built a couple of apps with Tauri V2 myself.
I think it's been awesome. I mean, I wasn't sure if it would work. I mean, there's something that's emerging now that I'm seeing more projects do this. Like Redwood.js has this. I think TurboPack just released something where you run a CLI and it opens up a localhost tab in your browser to show you some like fancy UI about your app. And I'm really excited that people are kind of catching on to this idea because I just do not like CLIs at all. I've actually been on CLI teams.
We just finished recording a podcast. We're like, what's the hype on TUIs? I love a terminal app, but like...
So,
buttons are good.
I previously worked at Vercel and I worked on Turbo Repo, and I didn't do a lot of the work. Chris, my colleague, did, but we implemented a TUI in Turbo Repo, and a lot of people were very excited about it, and I'm happy for them, but can they be happy for me too? I'm not excited about these things, and so I've always been a user of like Git Kraken. I've always been. I use like Yak, and I used to work on Insomnia, which is Yak and Insomnia are both kind of like Postman alternatives tools.
Yeah, Yak is cool.
Yeah. So, how is it that I, get my job done with all of these CLIs? I have a trouble with it. So what I did is I made this proof of concept called Instant Tauri. So you can go npx Instant Tauri anywhere right now, and it opens up a Tauri app. And it's just a nice little, it's like 9 megabytes, okay? These are not big apps. And something I think I want to stress to people about CLIs that they may not think about is, for websites, we discuss this concept of bundles a lot. We're like, oh, if I bundle the app, and you might have lots of other things. So if you pull in a dependency that has Lodash, but somewhere else had Lodash, it's like a negative, it's like a net nothing to add this project that uses Lodash. But when you have a thing like a CLI, all of the node modules come in, it becomes like this black hole, and very massive situation. But with Tauri, you deliver to your end users a static binary. And that's all. They just run the binary. There is no other junk in there. And so it's like 9 megabytes for everything. And that's very fast to download, much faster than, npx for, some CLI for node modules stuff.
Yeah, I've gone down the hole of just like bundling node and bundling Bun. And it's at the time it was like 200 megs. And I know Bun's got it under 80, I think now, but like 9, you know?
Yeah, that's good. One of the things that was challenging, though, I mean, I've liked it. I love Rust, so I have to say that I'm a bit of a fanboy and have been for many years on the Rust train. I'll admit that, but that was one of my biggest reasons. Another reason is that there's just stuff that you can't do in the browser. So if you have a tool like Typeslayer that's like shelling out to TSC, the TypeScript compiler, or calling native things on your computer, you just will never be able to do that in the browser. It's like security, like been blocked off for 30 years type of thing. And the alternative is something like Electron, but then now we're talking about a big thing that you have to install. And worst of all, you're still using JavaScript.
Yeah.
Which kind of stinks.
Is that the worst of all? We love
Yeah, hold on.
I'm just
Listen, clearly I do too. But I really don't think JavaScript is a good tool for the back end. And I know that's a hot take to some people. I'm sorry for you if you disagree, but like if you're trying to do multi-threaded things, if you're trying to do, I don't know, there's just lots of situations where, Typeslayer is a good example. Actually, we're talking about this big JSON files. JavaScript cannot hold in memory a string larger than like 600 megabytes. So to get around this, you do streaming and buffers and things. There are ways around it to process stuff, but like it's very cumbersome. Rust and lots of native languages for Go or whatever. On the other hand, like they'll take as much as you have memory.
Yeah.
You have 64 gig of memory, they'll take 64 gigs of file in. And so there are just problems that you hit. And I was hitting those problems. Actually, Typeslayer was originally written with a Node backend, like it was a TRPC that I was using. From there, the next problem is how to package it. So Wes, when you did this stuff before, how did you package, like how did you target Windows and Apple Silicon and all that stuff?
Yeah, that's a good question. You just lean on the fact that Node runs everywhere, I believe, but you get that absolutely massive bundle, right?
Yeah, you got to bring in the whole Node ecosystem.
Yeah.
Well, the way that you get around this problem, so you have a problem on your hands where you have a binary, and it's like a binary is just like a single file executable, and you can't run a Linux binary on Windows, and you can't run an exe file on a Mac, right? So what do? And the trick is, so I publish Typeslayer is the name of the npm, but I also grabbed the organization at Typeslayer. And so if you go to that on npm, you'll see at Typeslayer /Linux-64, at Typeslayer / Darwin, which is the code name for Mac, ARM64, which is Apple Silicon, and at Typeslayer / Windows or whatever 64, Win64. And the way you do it is I pulled this trick from ESBuild. In your CI, you build. You have like a runner build each of these things natively. So you have an Apple Silicon GitHub Action runner. You have a Windows GitHub Action runner that they're compiling in Windows, compiling in Apple Silicon, whatever. So you're cross-compiling now. And you publish all of those NPMs, those sub-package NPMs, the at Typeslayer ones first. And then if those all complete, in the one that your users actually invoke, you have a little post-install script that is like 30 lines long. It doesn't do a lot. Okay, we're very scared of post-install scripts these days, perhaps for good reason. And you just select the optional dependency of the platform that the person is on. So you just try to figure out, you detect their platform.os or whatever, and then you serve them the right binary. So at that point, they would download the right binary, which keeps you from having to download, like imagine let's say your thing is 100 megabytes. Well, like if you're targeting 5 platforms, if you didn't do this trick, people would have to download 500 megabytes instead of 100. Yeah.
That Homebrew works like that as well, right? You brew install something, and then it will go off and download the actual one that it needs, given that you're on ARM or Intel or whatever.
So I hope people catch on to this idea, and I'm gonna hope to make. I'm really focused on getting Typeslayer released right now, but and out to the public, so to speak. It's kind of in a preview. But I really want CLI makers, to understand that this is a viable option, that they can pull up an app. And there's lots of apps out there. Like even think of something like Webpack type of things, or ESBuild, or bundlers, linters. Like how cool would it be if you ran Biome or OXC and it popped up a window kind of showing you the files it's looking through. You could sort of see your config and where everything is. Like you could interact in a much more intuitive way, I think.
I'm glad that you're advocating for GUIs here, because we just had this conversation. I love it.
GUIs are awesome. I do want to talk about the performance of TypeScript a little bit more,
Let's do it.
And how important that is in the age of AI, because like let's say you have an absolutely massive code base, and part of the way that AI knows what code you want to write is it runs inference on a lot of your functions, and if that's slow, I'm assuming that means that your inference is much slower, your AI is much slower. Do you think that having performant TypeScript so that the AI can just rip through your code base and understand what it looks like is important?
Absolutely. And I mean, this was one of the biggest motivations for performance was the reason for TypeScript, moving to Go, right? But like beneath, as a sub point beneath that, why does performance matter? There's really three things. The first two everybody's familiar with. Number one is how long it takes to run your CI, right? You're going to be blockaded on your CI by a long type check because everybody is going to, want a type check before they'll submit merge a PR. The second thing is how it works in your editor. Like, we've all had this experience where you're trying to you hover over something and it feels like you need to go get a cup of coffee before it'll come back, Like that's a very painful experience and slows you down. The third thing is the new one, this agentic programming situation where you have agents going out and doing work on your behalf. And they, just like you and your editor and just like on your CI, are beholden to the speed at which TypeScript can deliver them back information. And so it becomes a whole new world if it's like almost instantaneous loop that you go through. And that's why it matters. And, to some projects, it doesn't matter because they don't have a problem. And so I have to stress with a tool like this, you may take your car to the mechanic and they say, it looks fine to me. And, you just need a new oil change or whatever. And that's not a bad result. But for some projects, you really need that oil change.
Totally. Yeah. That's something that I think people don't understand. It just really how big some of these projects are and the huge benefits. And also just like the simply how expensive it is to run some of these CIs, Like if you can cut out, I've heard stories of people just cutting days and days or months off their CI, which is a lot of money if you're paying to keep servers running. Or having to spin up new servers every time you want to type check something.
Not to mention the most expensive problem, which is innovation cost. Like you're suffering, all your developers in your company are, even if it's not a large project, I think some of the smallest projects need to go the fastest too. If you can't move quickly, it's a huge issue. And like I said, some projects, they don't have they pull up Typeslayer and they go, I don't see anything wrong. And it's like, yeah, because there's probably not anything wrong then.
Yeah.
It's possible.
Yeah, we had Zach on from RS Pack. He's making like a Rust version of Webpack, and he works at ByteDance, a TikTok, and he's like once things pass, I think he said about 10 minutes. If your CI takes 10 minutes, then people click away and they do something else, and that really slows innovation down at the company. So if you can get that like PR under 10 minutes, you put in the pull request, you get somebody to review it, you get the thing approved. If you can do that all in under 10 minutes, then just like the ship fast and break things, that whole mentality we have right now, that becomes doable.
Does the new Go-based compiler, though, change the landscape here and how much faster it's going to be? I haven't even gotten to personally really feel that.
Okay. My personal opinion is it does not. And the reason is, over time, these kinds of problems will come up again. Have you heard of this thing where you add a lane to the freeway?
Yeah.
And then
one more lane. Yes.
Just one more lane.
Yeah.
One more lane. And the types, I think they even talked. In fact, maybe was it you guys that I saw that the TypeScript team talking to about this concept. Daniel brings it up sometimes, talking about TSGo. I think that in the short term, it's going to relieve a lot of pressure, and I think it's going to open a lot of opportunities. There are things like higher kinded types that are exciting and sort of interesting little tricks you can do in TypeScript that are not super duper feasible. Like I think Effect has sort of figured it out, but it's not a great thing right now. But TypeScript Go kind of lowering that upper threshold is going to allow some cool new innovations in. But if you have a matrix multiplication that's creating hundreds of thousands of union members and it takes 10 minutes, but it's 10 times faster, so now it takes 1 minute, but it should be 0 seconds because it was just wrong, is that really a win? It is a win.
Yeah.
But what's going to happen is that 1 minute is going to become acceptable. And then that's the thing with the exponential growth is that, over time, I don't think it's going to be long before people are like, oh, TSGo is so slow. It's because I think that's why it's important to make, I think that's what's exciting to me about a tool like Typeslayer and other tools. There's actually others there. There's a TSPerf org that was kind of created. There's a tool called Attest by this guy, David Blass. Attest does a little bit of this, trying to tell you information about how slow your tests are in the types in your tests are, and it kind of measures this with the TypeScript compiler or API. So as we get more visibility, then we can start to see like solutions come about and people like, I think a lot of libraries don't know too, is another thing. Like I've had library authors this week contact me and say, I had no idea that I was doing this thing that, in a user's code base is causing problems. And this is a big issue that library authors have in general. If you think about it, like in your library's code, it doesn't use your library most of the time.
Yeah.
So how do you know how well it works? Like you have your tests, so it's like you can play with it in your tests.
People using it in a weird way that you didn't expect it. And all of a sudden, boom, this thing is crazy big.
Right.
Yeah.
Well, here's a question is, you obviously love different programming. You're not like a JavaScript lover.
No.
Should and will there be something after TypeScript? Should there be something new? And if so, what would that look like?
I'll shout out my friend Dan Vanderkam. I got his book behind me here, Effective TypeScript. Dan and I were talking the other day, and he said something that I cannot get out of my head. And I said to him, I just hope that TypeScript is not the last language. I hope that Rust is not the last language. Like I hope that this continues, and I don't want TypeScript to be the only thing forever or anything. And he said to me back, I think we know the last language. And I was like, what is that? And he said, English. And I think I don't know. I didn't know what to make of that when he first said it, but it was very, I don't know. I'm not on social media. Maybe this is not interesting and people say this all the time.
No,
I'm not sure, but
I don't know if they do, but
is that like an AI thing? Is that what you're getting at here? Okay.
That ultimately you can imagine, 5 years from now, we might not be, just like we don't work with machine code a lot, just like we don't work with assembly a lot, just like we don't, it's just like the level of abstraction, if you look back over the last 100 years of us trying to mechanize things and, through computer science, I don't know anything about metallurgy, right? But that doesn't stop me from being able to use a computer. I don't need to know anything about metallurgy. And as you keep going higher and higher in levels of abstraction, where could that, if you think of the logical conclusion of that, where does it end? I mean, I guess actually not English. It ends with a thing that I attach to my head that reads my thoughts. Yeah. Maybe that's the last programming language, actually.
Yeah,
sorry, Dan.
Right. You think about this all the time, but back when we were first learning how to program, everything felt like, why does this abstraction, why is there so much just friction in learning this syntax or this abstraction when I can express things more clearly through English?
One of my favorite takeaways from the Doom project is a couple people complained, and one guy really went far with it, that they were arguing. I think it was on Reddit, because there's a lot of arguing on Reddit for some reason.
Oh, of course, yes.
And someone was saying it's all in TypeScript types. And this guy responded back, it's not possible that it's all in TypeScript types. There is a JavaScript function somewhere, because Doom is running in C, and C has a main function, and something somewhere has to call the main function. And I just love that this guy said that, because I thought the same thing. I mean, there was a day when I was like, yes, but Doom has a main function, and I don't have how am I, it's how does that even work? That's that's the beginning point of your program. You can't go deeper than the main function in C. That's where it starts. It turns out the main function is an abstraction too. There is stuff beneath the main function, but you don't, as a programmer in C, get access to that. But there are things in there. There is stuff going on. And if you get in there, and I had to do this, and learn, how does that actually work? How does that abstraction, there was a day when I was looking around okay, so I have this abstract definition of a computer that can run a thing. How do I turn it on? How do I power up my TypeScript type computer? And I had to create a thing that would kind of boot the computer. There's a bootstrap initialization routine that at the very beginning of the thing will start the computer, and it does the thing that the main function does. It sets up the first arguments that you're going to pass to the first function, and it gets memory initialized, and it does all of the stuff to turn on the computer. And it's just very eye-opening to me, because that guy, I mean, I relate to him so much, you know?
Yeah, somewhere it's a voltage spike that's starting all of this.
Yeah,
right?
exactly. Yeah.
Oh, that's a good way to think. Just peeling it back, all these different layers. But then, at the same way, I often think about will there be another TypeScript? And I don't think so. I think
I don't think so. No.
There's not going to be like a better TypeScript that everybody moves to. There's going to be another abstraction level that sits on top of it that we all use.
Yep.
And then you can do consulting for all these old legacy TypeScript systems.
I mean, if it's anything, I would say it's probably WASM. I'm definitely very big on the WASM train. We didn't get into the architecture, but the Doom and TypeScript types project was done by making a WASM runtime, and actually it can run other things. So if a couple of people have told me, Dimitri, you really sold yourself short here by just talking about Doom so much. You built a full WebAssembly runtime in TypeScript types that can run.
Oh my God!
It can run other programs too. I just, because of my mindset, I never thought Doom would be possible, and so. Like, people have asked me, why did you go from nothing like this ever having been done, not even close, to like all the way straight? You drew a straight line to Doom. You didn't do you could have done Tetris and then like Pokemon, and you could have built up in smaller pieces. How did you go from nothing to Doom? And the reason is because I didn't think it was going to work. So if your mindset is, I'm going to find the thing that breaks all of this, why would you play around with Tetris or Pong or something, right? You just go straight to the thing that's going to be the hardest to show why it would fail under pressure. And so WebAssembly has a lot, I think, to offer, and there were reasons in the past not to use it, but in this past October, we had a release where WebAssembly got a lot of stuff added to it. It has 64-bit memories, multiple memories. You can do things that were completely infeasible before, shared processes and other things, exception handling. And I think that the cat is out of the bag now. WebAssembly is ready for, imagine, a thing like Photoshop being delivered in a WebAssembly format. It's ready for that now. It's just a matter of people adopting it, I think. We'll see.
Where do you go to stay on top of the WASM stuff? Because it feels like such a mysterious well for someone like me.
I have bad news for you. The only thing that I used was the spec. And it's written with fancy functional programming characters that show you ways to apply things. I just did it instruction by instruction, and I wrote lots and lots of tests. How I heard about that is actually because, I run this thing, SquiggleConf, is a conference for dev tools we can get into, but one of the speakers came this year and talked about, we like to have people come and talk about WebAssembly, so one of the speakers came and talked about that, and that's where I learned more about some of these things, yeah.
Yeah, let's talk about SquiggleConf, because that's like one of the confs that I always see pop up as being like, wow, I gotta make it to SquiggleConf.
Oh yeah,
sometimes.
Thank you. We'd love to have you.
Yeah. Oh yes, let's do that.
How it began is I have a meetup that I've been running here in Michigan TypeScript. There are a bunch of us here taking charge of it. And if you're from Michigan, it used to be called SEMJS, Southeast Michigan JavaScript, but we don't write JavaScript anymore, so got a little refresh. And I had this guy Josh Goldberg come out. Josh is the well known as the maintainer of TypeScript ESLint, and so I pick up Josh in the car from the airport to come speak at my meetup, and It took like 10 minutes before he and I were both like, why is there not a DevTools conference? Why is there not a conference for people who are just interested in tooling and want to share and cross-pollinate, populate ideas about tooling? And he came and did his talk. It was very cool, very good talk. And it kind of stopped for, that was the end. And over the next couple months, we kept in touch. And we kept talking to each other more. And one day, Josh came to me and said, dude, let's just do it. Let's just do it. Let's just make a conference. Let's start it. Nobody's going to do it. We kept waiting for somebody else. And so, SquiggleConf was born.
That's amazing. How has that process been, throwing a conf? That seems like something that I never, ever would want to get into.
That seems like a hard thing to do.
Do not recommend. It can be very soul crushing. It can be very uplifting. There's lots of ups and downs. These days people, I guess it wasn't like this before the pandemic, but it's apparently very, very common for people to wait until the week before, the day before, right before the conference to buy their ticket. You have to imagine, we published all of this about our, we're 501c3 and we have open books so people can see what we, spent. But you're talking about losing potentially tens of thousands of dollars in a single year if people don't show up. And it's very scary to do that. You're flying speakers from all around the world. It's a lot of logistics and coordination, and you want people to have a good experience. There's lots of ways that a conference can go poorly, and there's only a few ways that it can go excellently. So you have to really make sure that you keep it on, keep the train on the tracks, and make sure that everybody has a good experience. And you can't do everything right, but we try to make sure that the core deliverables are there, and people have a great experience. And it's a cross-language conference too, which is something that's fun for us because, like I said, I worked on Turbo Repo. Okay, well, Turbo Repo is a tool, or RSPack for that matter, right? These are tools written in Rust that target JavaScript. But where does a person go to talk about that? What conference do you submit to? Because if you go to a JavaScript conference, well, like, you can't talk about any of the cool Rust things that you're doing because they're not that language. If you go to a Rust conference, like, they don't want to hear about JavaScript at a Rust conference. It's like they're not interested. So there's a home here at SquiggleConf for these kinds of people. And every year we've had people from, representation from Go and Zig. And, this past year we had someone from Gleam. Like, he was so excited. He's he works on this boutique language that not a lot of people are using yet because it's still a smaller language. And he had this thing that they figured out how to do with their snapshot testing. And they just really wanted to share, like, other languages could do this exact same thing. There's nothing Gleam specific about this. But where can he go? They're not big enough to have a conference of their own. And I just love the idea of having a platform for people to share these ideas and, get together.
Yeah. Yeah, that rules. What do you, quick hit. What are your thoughts on Zig?
I think I've used Zig only for like cross compilation stuff. It's like freakily good at that for some reason. I'm really happy that Zig exists, but I also kind of wish that it didn't. I don't have any, I think Zig is way cooler than JavaScript for that matter. Like I'm all right with it. It's not like a problem, but I do get a little bummed when I see there's like a trauma that comes with being a long-term JavaScript developer where like you see JSLint, and then it becomes JSHint, and then it becomes ESLint, and then it becomes TypeScript ESLint, which never even really merged, and it was like a whole thing. Or yeah, we skipped TSLint in the middle. Okay, and then it becomes like Biome and OXC. I mean, we're talking like the wheel just keeps being reinvented over and over, and I feel so bad for people who poured out all their energy and effort to making a tool that only was really used for 2 or 3 or 4 years.
Yeah.
And that's kind of the way I feel about like languages in general. I think small languages are cool, but I don't think there should be that many. Like, I think like Rust and Go have definitely carved out a home for themselves. Zig is a weird intersection of all the things that are nice about Go and some of the things that are nice about Rust. And maybe that's what makes it strong. And that's why people love it so much. But I've never written much Zig. I mean, I've written 100 lines of Zig, I haven't done much, but I do worry about like it is natural and normal. There's like a natural selection process that happens with languages. But as we've seen, it's not always the best language that wins. Sometimes it's the one that's the easiest to get started in.
That's why JavaScript is so big, right? It's definitely not the best language.
Can I tease something for you?
Yeah.
Okay.
Yes,
All right.
please.
There's a secret that I would like to expose in the JavaScript world, and I'll expose it now.
Expose it. Yes.
But I'm gonna make a video with this. I was talking to I won't say who, but I was talking to someone you'll all know about coming on and doing a video with this. JavaScript 1.0 is well known to have been kind of like quote unquote written in 7 days. I got curious one day and I spent way too much time finding I booted a Windows 95 VM, which is really hard to do on modern hardware, by the way. I thought it would just be like you open up VirtualBox and get the image. No, it is challenging. Then I went even farther to connect it to the internet, which you need like Netscape Navigator version 2.001 gold or something. And I found like the first version of Netscape that shipped with the first version of JavaScript. And I booted, and now, of course, like no web page runs. Like I think example.com I could get to come up because it's got like, one HTML tag. But the point was, I wanted to see what I could run in JavaScript to see like, what is JavaScript 1.0 really like? Like, what is this thing that we've all heard was written in 7 days? And can I tell you, there is almost nothing there. It did not have arrays. It did not have... Yes, it does not have undefined. It doesn't have exceptions. It doesn't have lots of things that we think of as being completely core to the language. It doesn't have first-class functions. You can't pass a function to another function. There are so many things that are like absolutely critical to everything. It doesn't have switch statements. I mean, it's like what it was in version 1.0, if you actually go and use it, was actually very close to nothing. I'm not trying to throw shade. I think it's actually awesome that it started at such humble beginnings, but I think like it's really cool to like, so I got a whole dev environment going up where you have like Notepad open because of course there's no like IDE.
That's amazing.
And you can like run, I got the loop working where I could like save it and like run the file and we could see what happens. And there are just so many, like, you know, instead of arrays, what did they do? Well, you know, you have objects. So, and there wasn't, the object syntax is like missing. But anyway, you just put like a key, like you want 0, you just add a key of 0.
Yeah,
you want
zero.
1,
Yeah,
a key
yeah.
of 1.
That's technically how arrays still work.
Yeah. So, yeah, it's interesting. So yeah, that's a fun thing I hope to do on Michigan TypeScript in the future is a little video highlighting that just for fun.
I got one more random question. I don't know if this will be good enough to make it in, but you seem like a pretty smart guy. You seem to love learning and getting into the weeds. I'm curious if you have any thoughts on people who are just using AI to poop out all of their code right now and not continuing their skill set into learning more things.
I'm good with it. I think this industry has grown so much in the last 10 years. And I think that most of us who have been doing it for a couple years have worked with someone and you've had the thought about them that like, do you really love this? Or you just did this because somebody told you would make a lot of money?
Yeah.
And I think that like in the long term, I don't know if we need more software engineers than we have now. I think we need software engineers to be more capable. We need more like, so I look at AI as a capability enhancer. It allows me to do things like Typeslayer has a problem with, I don't know, it doesn't work with glibc version 2.39 and below because there's some Linux thing. I deeply do not care about learning how to fix that. Like, I really don't want to do that. And I'm not someone like, as evidenced by the Doom thing, like I will take the time to learn things if the situation arises. It's not like that. But I think that sometimes we don't have the power to pick and choose. And I also like that it gives you a chance to learn things that are outside of your range. Like you can, if you want to learn a new language, but you don't know somebody who knows that language. How do you, even like human natural languages, right? It's the same way. Like if you don't have someone to speak with, it's going to be really tough. You know, it's only so much fun with Duolingo in the closet, right? You know, sitting in the dark with, you know, so I think if you can come out into the open world and engage, it becomes a little easier. And AI gives you that opportunity. I think there are a lot of ways in which it's made life worse too, that I think we're starting to see now. You know, if anybody who's trying to build a computer right now, you know, they're, you know, Crucial, for example, they, you know, they just said, we're not making RAM for consumers anymore. Tough luck.
Yeah. Samsung is stopping their SSD for consumers, not their NVM or whatever, but their SSD. Yeah.
So I think that there's going to be some bumpy, you know, some turbulence in the meantime, and we all need to be ready for that. The job market. So I just left previous company, and I'm, you know, going to my next one in January, which is the window that I had to. That's why I'm doing Typeslayer. Is I had a little like couple weeks here to. What can I do at this time? But in that process, I've learned a lot about like where the industry is at right now, and there's like strange levels of desperation at the same time as. You know, I think it's like more aloof. Employers are more aloof than they used to be for hiring. It's like less of a priority now. And I think that we're going to find out that there's a lot that AI can't do. Actually, advanced TypeScript types tomfoolery is something AI is totally terrible at. It is horrifically bad at like type level programming, like of the sort that the Doom thing was made with. But, you know, so we'll see. I think that can be improved, but looking at the long picture, you know, I read this, the singularity is near when I was a kid. I don't know if you heard Ray Kurzweil, this like AI
the
book.
singularity is near, and the Age of Spiritual Machines. I think I read the Age of Spiritual Machines when I was in high school, and I think that book completely changed my mind, like completely blew my mind at the time. But it was like, at the time, that all felt so abstract that by the year 2040 things would be like this. And now that things are actually becoming like that book says it will.
It's going to be before 2040.
I'm like, this is scary as hell. Yeah. I was like,
you
know, when it was so abstract and far away, it was all like, this is magic. And now it's like, oh my God, it's overwhelming.
Yeah. And so I think like as time goes on, we're going to see how things level, but this is definitely a weird time to be a software engineer in this century. You know, and I'm not sure exactly where it's headed, but whatever it is, I don't feel threatened by AI, because like then like my job is to just become very attuned to harnessing it, so to speak.
Yeah.
And
Yeah.
it becomes a thing that I'm like, I'll always stay on top of it. Like I have to, so it does put pressure on us, but I'm a JavaScript developer. We got things changing all the time, everywhere. Anyway, like I can imagine that, other industries like Java developers and stuff where there's like less turmoil, or Rust or Go or any other language, they're probably not as used to the amount that they have to kind of like keep up.
Yeah.
That,
yeah.
they're going to have to learn. They're going to have to learn to keep up.
Beautiful.
Well, now's the part of the show where we get into sick picks and shameless plugs. A sick pick is just anything you're loving in life, enjoying, could be anything, podcast, physical item, who knows what, TV show, whatever. And then a shameless plug is anything you just want to plug.
What I would like to plug is this guy, Colin McDonald, the Zod founder, and David Blast, the Archetype founder, are working on this thing, Pullfrog, to, it's like coding agents in GitHub. They also have Anderist, who's a well-known TypeScript contributor. And I think it's really cool to see the stars align and see these guys getting together. Zod and Archetype are kind of like direct competitor products, and they're both super, super smart. I've gotten the chance to know all three of them, and it's been really cool to see them doing it. It's we'll see what comes of Pullfrog. It seems to be pretty exciting to see all these tools. Like maybe you've used Devin or these other agents that can kind of review your PRs for you.
Yeah.
I think it's a cool space to be in. Yeah.
Oh,
Yeah,
so I didn't
I've
realize
been-
they were working on that.
I've been seeing this, come together, and
should have
I've
them
been
on.
following it. Yeah, no, that and I'm honestly to even just talk about Archetype. That's a really cool project. I mean,
David also,
the-
I mean, if I have an honorable mention, David released this thing, Arc Regex, which
Yes.
is like doing.
That's also nuts.
Yeah, he has been. David helped me actually. David never committed a line of code on Doom, but I have a T-shirt and his signature on it with the Doom project because I was super stuck in the mud, and he sat down with me for 45 minutes one night and just like told me how to do it, how to make the machine chug.
Yeah.
And that guidance from him was so critical to making the project happen. So I think without him, it probably would have failed just on my own abilities. So
Sick.
Arc Regex is a crazy project because that's like, regexes are like famously very complicated things to do, and making a type safe regex parser purely in TypeScript types, I'm like, well, it does both, right? So it's a drop-in replacement for regex. It's just super cool. So
It's so
That's nuts. I can't
He's
believe
amazing.
he built that. Yeah.
Yeah.
I got to look at the code behind this thing because it's probably
It's clean.
pretty gnarly. Yeah.
It's not. Yeah, no, David has a little different style, I think, but it's like very meticulous code. Like he's not scrappy in the sense of like he'll get stuff done, but the code is very very thought out. You can tell someone put effort into it. He's a craftsman. He's a software craftsman.
I love
the
that.
type of person that needs to take on a project to parse a regex.
Yeah,
Holy
that's who you want.
smokes.
By the way, you really want a software craftsman to make your regex library, right? It's like very
my
important.
God.
You get the right kind of person on that job.
Yeah.
Holy smokes.
I'll give a plug to, so all this time we're talking about the Doom thing. The year got away from me and SquiggleConf took over a lot of time. But on Sunday, January 4th at 1 p.m. Eastern, I'll be doing a deep dive with Dylan Mulroy, a friend of mine.
Yeah.
On the, you know Dylan? Yeah.
Yeah. He just started over at Cloudflare, right? He was also a Vercelda
Yeah.
Cloudflare guy.
So Dylan and I will be working alongside each other again, which is going to be awesome. But yeah, Dylan and I are going to go through soup to nuts, top to bottom, the entire Doom code base. Like, how does everything work? It's going to be at least 3 hours long. And, most people I think don't care and won't be interested. But I think for like historical purposes, while I still kind of have it in my mind, it's cool to show people all the different things that had to be put in place, all the chips that had to be stacked in order to make it happen from a very, very technical level. So we're going to be looking at memory addresses from the first 10 minutes. Yeah.
Wow.
Is that going to be on the Michigan TypeScript YouTube channel?
Yeah, thank
Cool.
you. Yeah, I didn't even say where. Yes,
Yeah.
Michigan TypeScript on YouTube. We'll be live streaming it there. So look to that January 4th. It'll be cool.
Yeah, man, it's so cool to see Michigan TypeScript, quote unquote, on the map here. Like, as somebody who attended that meetup before, it was Michigan TypeScript for so long. Like, it's really cool to see.
We never intended to make it a YouTube channel, really. What happened was we were just recording the talks and we put them online. And someone gave a talk about how much they hate enums, and that talk just like blew up.
Yeah.
And suddenly, all the TypeScript people started making videos about it as a result of that. And we got thinking like, oh, this is kind of cool. We should do more stuff like this. And it kind of ballooned. Now we're 400 videos in.
Hell yeah. Shout out to the Michigan web dev scene overall. Thank you so much, Dimitri. Man, you were just...
This is awesome.
A delight in all facets of the word, man. You're so sharp. So we got to have you on again sometime. I feel like we could ask you a billion questions and just nerd out on some stuff. So thanks so much for joining us. It's been awesome.
Thank you. Yeah, it's been a pleasure.
Sick.
Peace.